Hi, and welcome. In this demo, we'll walk through how DBtune integrates with Aiven for Postgres and how you can automatically optimize your managed database with just a few simple steps. Here's what we'll cover: setting up an Aiven Postgres instance, visualizing the integration architecture, preparing the workload with seats, benchmark, setting up the DBtune agent, starting a tuning session, and reviewing results. Let's dive in by setting up our Aiven Postgres instance. We're already logged into the Aiven console, and I've created a new project called DBtune Aiven Demo. From here, we'll click Create Service to launch a new Postgres instance. We'll select Postgres as the service type. For this demo, we're choosing the Trial Full Platform option. Next, we'll choose a cloud provider. We'll go with Microsoft Azure and select Azure Sweden Central as the deployment region. Now we'll choose the Startup 16 plan, which includes 4 CPUs, 16 gigabytes RAM, which is more than sufficient for this experiment. We'll leave the rest of the settings at their defaults and click Create Service. Before provisioning begins, Aiven walks us through a few additional setup steps. First, we get the connection details, including the service URI, host, and default database name. Next, we'll move through the remaining screens. Secure connection, where you can manage IP filters for access control, add data, which we'll skip since we've already loaded our own benchmark. Then comes extensions. Aiven lets you choose from a variety of Postgres extensions. We'll enable pgstat statements a bit later, so no need to install anything here yet. And finally, the integration screen, where you can configure logs and monitoring endpoints. With that, we'll click Finish Setup, and Aiven will now begin provisioning the new Postgres instance. While that's setting up, let's take a quick look at how DBtune integrates with Aiven behind the scenes. At the core of the setup is your Aiven managed Postgres database. This is where all the queries and workload land, typically coming from your application backend or other connected services. To monitor and optimize that workload, DBtune uses a lightweight agent. And the great part is it can run anywhere, on your laptop, inside a VM, or alongside your infrastructure. Since Aiven is a fully managed service, we don't have direct access to the database hosts. So for this demo, we'll run the agent locally. Once running, the agent connects to your database and reads from pgstat statements to understand query behavior. And it also pulls system metrics like CPU, memory, and I/O directly from the Aiven API. All of this telemetry is securely sent to DBtune Cloud, where it's continuously analyzed. Every few minutes, the agent checks with DBtune Cloud. Has tuning started? Is there a new configuration to apply? If so, DBtune sends back a recommendation, and the agent applies it automatically via the Aiven API. Now that we've seen how the architecture works, let's set up the workload we'll be using for this experiment. For this demo, we're using the seats benchmark from our open source synthetic workload repository. If you'd like a step-by-step walkthrough on setting it up, check out our full tutorial. The link is in the video description. To save time, we've already loaded the seats benchmark using our synthetic workload repository, and the workload is currently running in the background. Let's switch to the terminal and connect to our Aiven Postgres database. To do that, we'll first go back to the Aiven dashboard and copy the service URI for the database we created earlier. Now let's connect using PSQL. As mentioned, we've already loaded the benchmark into the database. If we list the tables, we can confirm the schema is in place. Seats simulates an airline reservation system with complex flight searches, bookings, and customer interactions. It reflects a realistic enterprise workload with a 60/40 read-write ratio and high concurrency. With the workload running, we're ready to set up the DBtune agent. To do that, let's head over to the DBtune platform. If you don't already have an account, you can create one in just a few clicks. I'll go ahead and log in using the Login with Google option. Next, we'll create a new database instance. I'll name this one DBtune Aiven Demo. Select Manage as the service type, choose Aiven as the database provider, and click Create Database. This takes us to the agent setup page where DBtune walks us through two initial steps. Step 1 is to enable the PG-stat statements extension. This allows the agent to collect detailed query performance metrics from the database. Step 2, which is optional, involves creating a separate database user. But for this demo, we'll stick with the default Aiven user. So let's go back in the terminal and enable the extension. Now that that's done, let's configure the DBtune agent. The agent is available either as a precompiled binary or as a Docker image. For this demo, we'll use the binary version. We'll download the agent binary. And once that's done, we'll create a dbtune.yaml configuration file using the template provided by the platform. You can use any text editor. In this case, we'll use Vim. Next, update the connection URL field in the config file with the Aiven service URI. We'll need to retrieve a few Aiven-specific values, the project name and the service name. You can find both of these in the Aiven console. The project name is shown at the top left of the dashboard, and the service name is listed under your Postgres instance. Let's copy those over into the config file. The last piece we need is the Aiven API token. To generate one, click on your user icon in the top right of the Aiven dashboard, go to Tokens, and click Generate Token. Add a short description, set the session duration if needed, and then click Generate Token. Once your token is ready, copy it and paste it into the Aiven API token field in your config file. Once everything is filled in, save the file and start the DBtune agent. Note that data won't appear instantly in the DBtune dashboard. It may take a few seconds for the agent to begin collecting and reporting metrics. So give it a little time, and sure enough, we can now see several key metrics being displayed on the dashboard. Now that we've confirmed the workload is running properly, we can head to the Tuning tab and start a tuning session. We'll perform a reload-only session using the default settings. In this case, we're optimizing for average query runtime. In simple terms, we want to improve how quickly PostgreSQL executes incoming queries. So with that in mind, let's click Start Tuning. The first 5 minutes will be spent measuring the baseline performance of the system. That is, how the current PostgreSQL configuration performs in terms of query latency, our tuning objective. After that, DBtune will recommend a new configuration every 5 minutes. We'll fast forward now and come back shortly. All right, the tuning session is complete. And here are the results. With a 5-minute iteration window, DBtune delivered a 1.76x improvement in average query runtime, dropping from 2.54 milliseconds to 1.44. Transactions per second also increased by 1.26x, hitting close to 3,000 transactions per second. All of this fully automated with zero manual tuning required. Let's take a quick look at the configuration changes that made this possible. And we'll start by looking at the base configuration. These were the default parameters before tuning began. Now let's switch to the best configuration DBtune discovered during the tuning session. Here are a few key changes. BW writer delay was reduced to flush buffers more frequently and avoid I/O spikes. BW writer LRU max pages was increased 5 times, improving write efficiency during background writes. Parallelism was disabled, which can benefit workloads with short or high contention queries like seats. And remember, once tuning ends, DBtune automatically applies the best configuration so your database keeps running with peak performance. That wraps up our demo of DBtune's integration with Aiven for Postgres. To learn more, visit dbtune.com and start optimizing your databases today. The first 3 are free.